Let's find out the value of the given derivative. To begin with, we will consider u to be equals to inverse tangent of x divided by square root of 1 minus x squared, and v to be equals to sine inverse of 2x multiplied to square root of 1 minus x squared. Here, our goal will be to find out derivative of u with respect to v. But for that, we need derivative of u with respect to x, and we also need derivative of v with respect to x. To do that, let's try to simplify the expression on the right side of u using a trigonometric substitution. I'll take x to be equals to sine theta, such that u becomes equals to tangent inverse of, we have x, so in place of x we have sine theta divided by square root of 1 minus sine squared theta. Right. Now, this gives us tangent inverse of sine theta divided by, so square root of 1 minus sine squared theta simply becomes equals to cosine theta. That's because we are using here the identity that cosine squared theta plus sine squared theta, that is equals to 1, which gives us u equals to tangent inverse of the ratio of sine over cos is tangent of theta, and tangent inverse of tan theta will be simply equals to theta. Now, since x equals to sine theta, this simply means that theta must be equals to sine inverse of x. So that means u is equals to sine inverse of x. So let's label this as number 1. We'll find its derivative, but before that, let's also simplify the expression for v. So we will simplify the expression on the right hand side of v using a substitution. We will consider x to be equals to sine phi, such that v is equals to sine inverse of 2 times sine phi multiplied to square root of 1 minus sine squared phi, which gives us sine inverse of 2 times sine phi multiplied to cosine phi. So here we have used the identity that cosine squared phi plus sine squared phi, that's equals to 1. Furthermore, we also have an identity for 2 times sine phi cosine phi. So we have sine of 2 phi, which is equals to 2 times sine phi multiplied to cosine phi. That means v will be equals to sine inverse of sine of 2 phi. That means v will give us 2 phi, and since x equals to sine phi, which implies phi must be equals to sine inverse of x, that means v will be equals to 2 times sine inverse of x. So let's label this as number 2. Now we will find out the derivative of u and v with respect to x. Let's begin with u. So we'll take the derivative with respect to x. This is going to give us derivative with respect to x of inverse sine function. The derivative of the inverse sine function is 1 divided by square root of 1 minus x squared. So, and derivative of v with respect to x, so that will be equals to 2 times derivative with respect to x of inverse sine function. So that will be equals to 2 divided by square root of 1 minus x squared. So to find out derivative of u with respect to v, all we have to do is take derivative of u with respect to x and divide it with derivative of v with respect to x, which will be equals to 1 over square root of 1 minus x squared multiplied to square root of 1 minus x squared divided by 2, and this gives us 1 over 2. So that means the derivative of our given problem is equals to 1 over